we've looked at the cathode ray oscilloscope, and we now have to look at the waveforms which are produced depending on whether the X plates or the Y plates are connected in a cathode ray oscilloscope. So when alternating current is connected to the X plates and the time base is off, we obtain this waveform here, or it can be drawn like this. So it has arrows in two directions because alternating current moves in all the two directions. So the best one, you can draw it like this rather than drawing it like this. So when alternating current is connected to the Y plates, remember the Y plates cause a vertical deflection. So we shall obtain a waveform which is like this, So the arrows pointing in both directions indicate that alternating current is connected. So when alternating current is connected to the Y plates and the time base is on, so remember a time base causes a sawtooth. So we shall end up having, since it is alternating current which is connected, the arrow faces two directions, but it is sawtooth because the time base is connected. Then if we use a direct current, because direct current moves in only one direction and we connect the Y plates, then it will either be facing upwards, as you can see, either it will be facing upwards like this, or it will be facing downwards, but it should face in only one direction since we are dealing with DC and Y plates cause vertical deflection. Then if we connect DC, direct current, which moves in one direction, to the X plates that cause horizontal deflection, we either obtain a waveform which is like this or like this, but the arrow should face in only one direction. Then if DC is connected on the Y plates and the time base is on, time base causes deflection in both. Time base causes a sawtooth, so you can see the kind of waveform that we obtain whenever we connect a time base. So a time base is basically used to cause that sawtooth kind of deflection. Then when the X plates and the Y plates are all off and the time base is also off, we get a spot which is like this. As you can see, a spot which is like this is created. To remind us about the uses of a CRO, they are used, CROs can be used to measure potential difference, or it can be used as a voltmeter. It can also be used to study waveforms. It can be used to measure frequency. It can be used to measure the wavelength of a wave. It can be used to measure phase difference and timing of devices. It can also be used to measure peak values of AC and DC. More of the uses of a CRO over ordinary voltmeters are shown here. It has infinite resistance. It is not affected by high voltages. That means it cannot blow easily. Then it measures both alternating and direct voltages. Its accuracy is of course also more, and then it has no coil to burn out. Yes, so it also has some disadvantages, like it is bulky, it requires some skills taking the readings, it is expensive. Those are some of. It also doesn't give direct readings, meaning that you have to do some calibration. So these are some of the disadvantages of using a CRO over an ordinary voltmeter or an ammeter. Yes. Then the advantages of voltmeters over ammeters, sometimes they tend to ask those. Of course, the voltmeters and ordinary ammeters are portable. They don't require skilled labor because they are already calibrated. They are cheap. They give direct readings. So that's why we prefer using them over using a CRO as an ammeter or a voltmeter. Then finally, the disadvantages of voltmeters and ammeters over ordinary CRO is that are also given down here. Thank you.